For the last 2 years, the AI hype train has been at full speed. Enterprises raced to secure GPUs, driven by the urgency to stay ahead, even before they knew exactly why they needed them. Now, those long-awaited GPUs are arriving, and the reality is setting in. Now what? Are organizations truly prepared to maximize these investments? Or are we seeing a repeat of past technology cycles where the rush to acquire outpaces the strategy to use? Today, I'm talking with two technical solutions architects, Andy Moser and Chris Braun, to cut through that noise in order to start thinking about the right way to think about GPU utilization. Andy and Chris will also talk about AI infrastructure and power considerations, the growing skills gap and workforce adaptation, and the future of AI hardware and innovation. This is the AI Proving Ground podcast from Worldwide Technology. Everything AI, all in one place. I'm your host, Brian Felt. Let's get started. Well, the AI hype train has been going on for more than 2 years now. Perhaps 12 or 18 months. A lot of enterprise organizations were itching to get their hands on a GPU, put an order in, and now they are getting those GPUs. They have those GPUs. How many organizations out there do you think, Andy, we can start with you. How many are sitting there saying, now what do I do? Or do you think that for the most part, the industry has an expectation about how to handle and what to do with GPUs once they open that box?
I think you're kind of at the latter half of the hype cycle on that a little bit, where you had, say 12 to 18 months ago, people couldn't get AI hit. It was crazy. ChatGPT, all that stuff came out, and it's like, I need GPUs. I don't know why I need them yet, but I need them and I want to buy them, and it's hard to buy them. So I'm going to get in line to buy them, and I get them. And then, 6 months goes by, there's a long lead time on that stuff because of the demand. So, what are you going to do with it when you get it? I think now we're getting to the phase where there are some people that have made those purchases, and now they're kind of taking a step back and like, okay, what do we really need these for? What are we going to do with these? And how can we best, leverage our investment on this with, the current state of things to get what we need out of it?
And Chris, you work out of the our Advanced Technology Center, where a lot of our clients are doing work related to GPU or AI workloads, et cetera. What are you seeing in terms of usage? What are people looking to do with them?
Anything and everything. Mostly, it was surprising me. I did a POC with a large financial, and I was surprised how much they already knew about the technology. I mean, investment trading is what this firm was in, and they do mathematics all the time. So it's just another way to kind of ramp that up. But that's just one application, right? There's video, there is streaming the GPUs, there's sharing the GPUs between systems. So, there's a lot of different things there. I think a lot of customers still aren't, exactly what do I do with it. But for those select few that have already been using GPUs for a while, it's shifting from, hey, I used to do video on this, but now it's opened up a little bit more of the processing power of what it can do versus a CPU.
Well, recognizing the fact that, maybe those global FIs out there are leading the charge, and, maybe the rest of the industry or the rest of sectors are lagging behind a bit. Should they be taking a cue from those global FIs, or are the use cases just different across industries?
I think some of the use cases are the same, and I would definitely, as most people know, money kind of starts where that use case kind of is. And if the global FIs are having a good advantage of how to use it, I think it'll trickle down to other different pieces and parts in different industries, right? But most of the times, the money starts, right? If Citibank or Morgan Stanley or someone is doing something with the GPUs, that kind of translates into other people, taking it from their footsteps.
And Andy, let's backtrack just a smidge here and level set. It'll be a very GPU heavy conversation here today. Walk us through the importance of a GPU. What is a GPU? And then, we hear about DPU, TPU, all sorts of PUs. What's the difference? Give us a lay of the land there.
So a GPU is a graphical processing unit. I think that's the actual term. I've always just said GPU, but it started out, in my mind is I just call it a video card of like back in the days of like, you had a computer at home, you needed a video card to see what was on the screen, to have the screen work. And then those over time got more powerful, and then gaming and then other applications kind of came along. And then you started to see them move into the data center. And then, where we're at today. I mean, I think a lot of it is they process information differently. It's like a lot of parallel processing versus like a CPU doesn't necessarily do that or do that well. So it can process large amounts of information like in bulk, for lack of a better word, faster than other things can. So, I mean, that's kind of what got it to where it's at with, with gaming and with like the AI ML space and all of that, where you have these LLMs and just these vast quantities of data that you're messing with, trying to, find something of value out of, and you need that processing power to do it quickly. I mean, you could do it in other ways. It just might take weeks or months or years to get there. Whereas with a GPU, you're constantly slicing that time down to get to where you need to be.
Back in the day when you had those game cards or video cards, as you call them, did you think you held the secret to AI when you were playing a game? Or
No, thought it may be faster for maybe a minute, right? You render the screen a little bit quicker. Maybe it makes your decisions a little bit faster while you're playing said game, whether that be Doom or whatever.
Yeah.
It was always like because I'm a gamer, I used to be, I guess, but like, that new GPU's out, and then, it's for 50% more money, I can get 5% more value out of it. So it's like you get to that top tier, and it's like kind of an arms race with some of that stuff where and I think it kind of can play into this space too with, always needing the most latest powerful GPUs and for your business use case, if it matters, like if it really matters, if you're going to shave 10% off of some task that's going to save you $1 billion a year, yeah, it's definitely worth it. So look at it in terms of that way, but like for like, everyone's else kind of in the middle.
Yeah. What does that say about the industry in general that, perhaps some of the clients that we have or organizations in general that come to us say, I need to do this, I need to run this workload on this GPU, and then maybe you're answering back, well, actually, you don't need a GPU. Like, what does that say about the industry? Is there still confusion about what we should be running on GPUs versus what we shouldn't?
I think there's still some confusion to that. I mean, that's always the experience with technology, anything, whether it's GPU, CPU, DPU, pick one, right? Sometimes what you may think is the solution may not end up being the solution, right? Like Andy alluded to earlier, GPUs might be better for a lot of parallel processing versus what a CPU can do, but you don't have to run everything on a GPU, right? You just pick a use case. And I think that's been consistent throughout, at least 30 years that I've been in technology, is you really have to hone in on your use case. What do you really need to do? What is your end goal?
And I think a lot of like the stuff we do in the ATC and now the AIPG part of the ATC, but historically, I mean, we've both been involved in like lab services for, I've been here 9 years. He's been here
almost 10,
almost 10, kind of doing a lot of the same stuff. You see, you'll get a lot of customers that will come to us and they have kind of an idea or a preconceived notion of like, hey, this is what I want to do, and help me do it. And then you kind of start peeling back the onion of what it is. And you can, it's an education opportunity really of, you don't really need that. I'll sell you it, but you don't need it.
Yeah.
And
sometimes
it's the opposite of like, oh no, this isn't going to work. You need more of this. And, but like having those conversations with the customers and stuff it's always interesting because sometimes people, they're really set and this is what we want. And, you've got to really prove to them why. And that's kind of a great part of the ATC, and the proving ground is we can do that. We have the stuff to answer those questions quickly.
Yeah.
Yeah. And sometimes it's, it's the opposite too, like where you're telling the customer, hey, it's this. And then you learn along the way that, it's something else, right? It's definitely, with POCs in general, you always go in with a preconceived notion or an idea that you want to to solve, right? The problem. But sometimes the problem may not be the thing, or the solution may not be what you thought it was in the beginning. And that's part of doing it, right? To figuring out the problem. It may not be this, but it could be that.
Yeah.
Could be right. You could be wrong. That's why we prove it.
Yeah, take me back to the to grade school, the scientific method there.
Exactly. I mean, we do that every day. I mean, we have a team of 70 people that take an idea from a customer and say, is this even what you think it should be, or should we be looking in a total different direction? And that literally happens every day, whether that be from a networking standpoint, a storage standpoint, compute standpoint, whatever. That's what we do. We try to prove, is it a viable solution to the problem you've given us?
Yeah. Let's go over, back to the idea of, an organization gets their GPU after waiting X amount of months after they ordered it. They open it up. Is it as easy as, is it a plug and play? Is it just, take out the CPU and put it in? What is the integration process into the tech stack, into the data center? From our perspective, we've done it plenty of times in the ATC, but what does that mean for listeners out there that, might be doing it on their own?
Well, don't take out your CPU because you're going to need that. Keep that in there. But it depends, I think, a little bit on the problem that you're trying to solve. Does it integrate with your current technology stack? It can. Again, that is the problem you're trying to solve. Like if you have an AI ready application, it will probably integrate pretty seamlessly. I mean, there are different pieces that an AI engineer has to learn versus an infrastructure engineer has to learn. I mean, I think Andy, you alluded to it in your RAG lab and others, where we all had. I was born an infrastructure engineer. I've been in infrastructure here for a long time, 10, 15 years, maybe even more than that. A lot of the AI PG stuff that we're doing today took another step back in retooling that, right? I was a Windows domain admin for a long time. I was a hardware guy for a long time. So I also had to step back and learn a little bit more Linux, a lot of Ubuntu, a lot of the NVIDIA products that they're shoving out, every day. So a retooling aspect has to happen with the people that you're doing it. So how does that, when you bring that GPU in, how does it fit into what you're trying to solve?
Yeah, and we'll probably get into that retooling, reskilling conversation a little bit later. But Andy, I know that's one of the things that you had talked about is just gaining those skills to be ready for that AI ready future. Any just kind of prelude to that conversation that we'll touch on later?
Yeah, I mean, the way I kind of looked at it and what Chris was just talking about, if I looked at, I'll just take my career for an example. I was also infrastructure, very similar backgrounds.
Yeah.
I would say in the last 18 to 24 months, I've learned more than I've probably learned in the past 10 years of just net new stuff that has gone along with AI, with its Linux, Kubernetes, advanced networking, storage, the GPUs, how all of that stuff plays together. It's a lot to learn. And it's changing so fast. It's hard to keep up. And I mean, this is my job. This is our job. We do this daily. And I mean, there's no way you can stay on top of it. So I get I'll watch YouTube videos and stuff at night of things that are interesting in AI. And then I'm I'll go down some rabbit hole. Hey, this is so cool. I want to figure this out. And then that, it's the next day and I've barely scratched the surface and now I have to go to work and I haven't slept. So it's really cool in that sense, but learning about it is definitely, it's a big opportunity for kind of everyone in a traditional IT world or for solutions to kind of retool and pick it up because it's everywhere. You can't do anything today without AI coming up, at least think about the things you do. There's AI in everything, your phone, your computer, your TV. Hey Siri, I want to watch this. Or, it's there. So,
yeah. Well, knowing that companies are so focused on advancing these AI strategies is almost alarming to understand. I read a study, I think it was Deloitte, that came out and said, GPUs in general utilized only to the 15-20%, which leaves a vast amount of capacity that's not being used. Mm-hmm. Chris, why is that the case? Why are we not? If we're investing so much, why aren't we utilizing it to its maximum?
It's some of the application parts that you're putting into it, right? sometimes to crunch those numbers, it may be sitting on that number crunching for 12 hours or 15 hours or 36 hours. But then once the problem's solved, what's it doing? It's sitting there idle, waiting for the next problem, right? And some of that can be said the same thing if you have like a VDI infrastructure, like where we support like some of the Omniverse clients. You're rendering something, it's done rendering. Now it sits and waits for the next rendering tool, right? And that's why I think some of the importance of time slicing or trying to share the GPUs more efficiently than just here's one box, you put it in and it sits there and waits for a workload, where you can run more distributed workloads across the system versus just dedicating a single GPU to this singular task or this set of one task, right? Where you like I said, this time slicing it or having it be it most efficient, right?
I would say too, like the underutilization aspect of it, it's not unique to AI or GPUs. I mean, it's across the board. And if you just look back in the history of things with, I'll just talk about things, when we first had servers, it was, I had an application, it needed a server. It was a kind of a one-to-one pairing. And then all along came, virtualization with VMware and other products. That totally changed the game.
Yeah.
Now I have this piece of hardware that for, 90% of the day was just kind of idling. And 10% of the day, it ran some job at night and it did its thing or after hours, whatever. But you're wasting that resource. And then you add something like virtualization on top of it. Now I'm bumping those numbers up to like, say, 60 or 70% of that is being utilized all the time for various different things. And then I'm consolidating, I'm shrinking workloads and things like that. Move up the stack with that, with some of the, storage, deduplication, all that sort of stuff. And then you get into the GPUs. It's kind of the same thing with a lot of the, the software, Run AI, Domino, like a lot of the stuff that we're using to slice up the GPUs it's definitely helped us with what we do in the AIPG for a good example, the RAG lab that we did the live labs and learning on, it uses a slice of a GPU. It uses 20% of one GPU. That's all it needs. So the rest of that 80% is given out to other things that can use it. So, with some of the tooling we have available, it's making that a lot simpler. So it's kind of like a virtualization aspect. You're driving up the utilization to better utilize the resources.
I mean, VMware is a great comparison.
Yeah,
it really is to what you're talking about resources from a GPU standpoint. I mean, when I got an infrastructure, it was stand up a Windows box and it was 1-to-1. Yeah. Right. Stand up a Windows box, stand up a Linux box. It did its job or ran its application. And then the next day it sat there and did nothing, waited for users to connect. And when we started virtualizing it, you started getting more horsepower or more out of what you actually purchased than it just sat there and kind of ran, right? It could run multiple things, multiple applications. And that was, I call it the CPU boom right there. Cores started going up and everything started to expand that. And, some licensing companies weren't very happy about that when that happened, when virtualization came along, but it allowed people to be more efficient, 100% more efficient on what they were purchasing to do the workload they wanted to do.
Yeah. I would say another comparison, Amazon Web Services, AWS. I mean, where that came about, cloud computing wasn't a thing until they had to buy all these servers to ramp up for the holiday shopping season. And then the other, say 8 months of the year, 9 months of the year, they didn't need it. So what are you going to do with it? It's like, I've got this warehouse I only need for 3 weeks. How can I leverage that for the other, 49 weeks out of the year, whatever it is? And that's kind of where we're at with the GPU stuff too.
Yeah. I find it interesting that the two of you are kind of going back in your careers to justify how we'll be moving going forward. So if history is kind of that great teacher, what are the lessons learned that we'll be applying? Or is it a new playbook going forward?
I think, first part of that is like with anything, it's going to get more efficient, right? I mean, when virtualization first came out, it was in pockets. Right. And it was like, hey, we got this one. And a lot of people virtualized Windows off the gate because it was easy. And it was, sorry, Bill, but it was kind of dumb, right? Windows was easy. It was a graphical interface. A lot of people knew how to use it. It didn't take a lot of tooling to get there. But again, it was trying to find an inefficiency and make it more efficient, right? And I think that's kind of where we're at now with the GPU and AI boom. Is we have all these GPUs. How do we slice them? Run AI is a great example. How do we make this box that's sitting there idle be more efficient? And I think a lot of the players that are coming into the market now are focusing on that. How do I make this more efficient?
I think it's an education thing too, where like, not to rely on how old we are with our careers, but like when virtualization first started out, there were a lot of like non-believers. Like, this is, you are not taking my application. You are not doing this. This is not going to happen until, okay, we'll get to you in 6 months. We'll come back. We'll get you. Like, and then, somebody higher up has to say, hey, you need to go do this. This is what we're doing. And it works. I mean, so proving it works. I think there's less of that with AI because of those past experiences with emerging technologies like virtualization and things like that, where, okay, hey, this isn't bad. I don't need 10 GPUs. I really only need 2. So now that I've figured that out through, proper scoping and, defining what it is I'm doing, through POCs or labs or whatever it may be here, you figure that out. And so you make that educated decision versus kind of a shot in the dark of like, I'm not doing this because we never did it.
Right.
So.
Well, the both of you have mentioned slicing a number of times. Explain to me a little bit more about what slicing is and how have we gone about slicing up GPU capacity, I guess would be the right term.
Do we call it slicing or fractional?
Fractional, probably a better word, maybe.
I would say fractional is probably a more industry standard word,
Yeah.
but it's the same thing, fraction slicing.
Yeah.
I mean, like the one I'm the most familiar with in terms of a consumer, I've not actually built it or stood it up, is Run AI. So a lot of the things I use leverage a GPU, which is basically you have a Kubernetes cluster that has nodes with GPUs in it. And, there's a GPU operator, which is a piece of the Kubernetes side of the house. I won't go too deep into there because I can't. But, and that says, hey, I have a GPU and it's this spec. And then you can say, hey, I need a GPU that's got this spec over here. Like, here's my application. It needs this. And it's going to say, oh, I have this over here. Here you go. You can have it. How much of it do you need? I'm going to say, I'm only going to give you 20% of it. So I'll slice that up. Fractionalize that and say, to the application, it looks like they have an entire GPU.
Yeah.
Like you can run commands in there and it'll say, you have this GPU, and you have no idea. But like under the covers, a tooling like Run AI is, only giving you that percent that you're allocated to use. So, yeah.
And is that GPU as a service, or is that a totally different field?
It could be considered GPU as a service.
Yeah, I would say like you could, if you get to where it's fully automated, you could say, request. It could be down to like, say a ServiceNow request for something like I need a piece of infrastructure, and it's a checkbox like, hey, I need, 10 gigabytes of GPU memory, or however you want to, like, if you want to do t-shirt sizes or things like that, right, or more granular. I think it's more granular.
I think it's way more granular than the traditional GPU as a service.
Yeah.
Where you're passing a physical GPU to a box, right? You're, at that level, when you think about it, like you're getting more out of that GPU, I think, from an application standpoint, with fractionalizing it that way, versus if you're just dedicating an entire GPU as a service. Like nothing like Liquid is a company that kind of does that. It's like a PCIe repeater, and they have their own switch.
Yeah.
And you put GPUs in that chassis, and then you can physically present a GPU to a system that wouldn't be able to hold it. So like a Dell single U or an HP single U server, you could put an A100 in it, and it wouldn't even know that it can't physically hold an A100, right? That's one part of GPU as a service versus the other way of thinking it, which is the fractionalizing it, where you're doing GPU as a service that way. I feel like the second way is a little bit more efficient, right? Because again, you're not pigeonholing that GPU into one workload.
Right.
You're allowing that GPU to go to multiple different workloads as you see fit.
Yeah, well, you started to get into it there, but for any listeners out there that might be thinking, okay, fractional GPU as a service, or I just have a GPU that's being optimized 10, 15% of the time, what do organizations, how would we advise them on what to think about or consider when they're considering fractional versus whole GPU versus GPU as a service?
I think most of the fractional use cases have something to do with containers, right?
Yeah.
It's like 100% of it, right? I mean, you can do containers in the liquid route too, right? Don't get me wrong, but I think you optimize the GPU when you go way more into the container rabbit hole, which is kind of what, the AI stuff is mostly focused around. Well, how do I run this container and run it this way, right? So fractionalization of GPUs, going back to that, is more container based. Again, it's all about workloads, different workloads. If you go to the liquid environment, you could run Docker or whatever on a liquid server and do it that way. But they're probably looking at, like a VDI or follow the sun kind of model, right? This in the morning, this hardware does this, and I flip it to do that the next day. I've seen a lot of people use Liquid in that realm, and we kind of have a launchable lab in the portal that kind of shows that. Maybe it's schedulable, but where it's that specific set of hardware versus a fractionalization.
Yeah.
I would say too, like, it kind of depends on the tooling you have available to you. Like, if you already are a heavy Kubernetes shop and you have all that knowledge and you have all that skill, it's going to be a little easier to pick up something like Run AI or something like that. Whereas, you also have a lot of people who, they can go to AWS, they can go to Microsoft, they can go to any of the cloud providers, and basically they're running all that stuff on the back end. They're giving you that fraction of a GPU, and to you, it's so maybe that's easier to get you started until you figure out what direction you want to go.
Yeah. Well, wouldn't the counter to that be latency if you're moving to the cloud?
It depends. I would say it depends on where your data is and all that stuff. If all your data is in the cloud, latency is not really an issue.
Yeah.
If your data is here, I hate to say it depends, but it does. So it's like, the application is, it always depends. But yeah. But if it's all in one place, for sure, it's not a big deal. If it's split, it may be something to definitely, look at your architecture with how you're doing it.
Yeah.
And you also have a lot of people that they're still just kicking the tires. So that's an easy way to kick the tires sometimes is, just throw up a credit card and somebody pays for it later.
Sure. Well, all the things we're talking about right now, or at least within the last couple minutes, it's all towards GPU optimization. Is that accurate?
Yeah.
Is the number that we're striving for 100%, or does it just depend?
I think that's it depends on your use case, right? Like when we go back to the VMware question, right? When was your cluster the best optimized, right? You have a 5-node cluster. You want to run to a point where you can lose a node.
Yeah.
You can lose 2 nodes. It's a sizing debate, right? As you get into that. I think so. As you go into the fractional method, it becomes more of that same kind of debate, right? Like your Run AI cluster, it has X amount of resources. Well, you don't want to be over
right
what you're allowing to come in the door, but you don't want to be 25% all the time either.
Sure.
So where is the happy medium?
Yeah.
At that point, right?
And you have things like, and I don't know the answer to this, so we can cut this out if this is bad. But sorry, I'll start over. In virtualization terms, you could share all those resources and you could overcommit big time. Like you could overcommit your memory and all that stuff a lot. And that was the beauty of virtualization. I'm not sure how that works really with GPUs yet myself, in terms. So I think so far it's been like, hey, we know, we have this percentage, you get 10, it always adds up to 100. Right? At the end, it's not 110, 120, like things like that. But figuring that out is, I'm sure if that's not here already, it's coming.
Yeah. Well, let's get into skills, because I know, Andy, that was one of the things that we talked about before as being an area, just constant learning. There's so much to learn out there. And you're talking about it from a personal perspective. What does that mean for IT teams or data center teams or, organizations in general out there? How do they need to, think about upskilling or learning? And what have you found to be the best way to go about that?
Wow. I can speak to my personal experience. I'll do that at the end, but like how organizations can do, I think it's a lot of the stuff we're doing here, like with the labs and learning, POCs. I mean, obviously a POC is a little bit more advanced than a lab, lab and learning in terms of how quickly you can access it. But like figuring out, I look at this as an opportunity to kind of also slightly reinvent what you do. If you're in IT, traditional IT, if you're an application developer, like how can I leverage AI to do what I'm already doing better, or to let me do new things that I didn't know about? And so look at it that way. Like a great example with, generative AI, I don't write code. I'm not a coder. Like it's like anytime I've had to do it in my life, I Google my way through it. It takes me forever and I don't understand what I'm doing. I just don't speak that language. It's just never something I was super interested in. But with AI, I've been able to leaps and bounds beyond what I'm doing. I mean, I don't always know what I'm doing, but I know enough now that I'm dangerous with this, and I can make some pretty cool stuff that 2 years ago I would have been like, if you would have told me to do that, I'd be like, all right, I'll see you in 6 months and it might work.
Right.
Like that sort of stuff. So take advantage of a big, online stuff. YouTube, I hate to say it, it's a huge source of information because you have a lot of this stuff is open source. So a lot of the open source people, they're just talking about what they're doing, LangChain, things like that, looking at they put out videos, daily of advanced topics. And, you can go from, 100 level to 10,000 level with some of this stuff and trying to work your way between it. But that's how I learned was, YouTube, reading blogs, and then doing it. Like a lot of it I did. I worked from home most of the time. I had a GPU and I found something, that was actually what got me to do this. I don't want to pay for one. I already have one. Can I do some of this stuff on my computer that's right there? And sure enough, you can. And that kind of got me deeper into it of oh, hey, I can do this. And okay, this is cool. And now I need a better GPU. And, go down some crazy rabbit holes of, stuff you can just do on things you already have that you never knew were possible.
Yeah. Well, that's getting into learning, but then there's a question of what do you need to learn? And I guess maybe the better way to ask this, and, either one can start on this. Where are the IT or where are the AI skill gaps that we see, or that we suspect to have within organizations out there?
Container is probably the biggest one.
Why is that?
It's just been more thought of as a DevOps principle for a long time, right? Again, going back to my work history and stuff, I was more of supporting an operating system, and not so much the apps. And I think the containers are virtualizing the operating system to a certain extent. So learning how to strip that down and do containers really well is one of the things that's going to push you over. That's the tool set. In my opinion, a lot more Linux skills, a lot more container skills is what you kind of need to help drive yourself if you have an interest in AI, right? That's going to be it's not the only thing, but it's definitely something that you should look at and get a part of and get in front of. That's going to be a really big skill for you to grow as an infrastructure engineer.
Well, Andy, getting back to, you talking about in your house, messing around with the GPU that you had, that's talking to a little bit of a culture of innovation, culture of experimentation. How much do we think that, our clients or our, organizations out there, how much of an experimentation type outlook do they need to take to really take AI to the next level or even unforeseen next levels?
I think a pretty big amount of experimentation. I mean, I think it kind of comes, if I looked at an organization from top to bottom, I think it comes somewhere to the middle to the bottom of the idea of, somebody gets an idea of, I want to do this, or, they look at how can I make something I have to do easier, or better, or that. And it's really that simple of I have to cut the grass every day. Well, now I got a robot vacuum. I don't have to do that. So now I can do other stuff. So it's something along those lines of figuring out, what in your world, your immediate world, and that your work world or personal, but, let's talk work. What are your challenges and how can I leverage AI to do that better? A lot of the stuff we do with is writing lab guides and documentation and things like that. Not necessarily the most fun thing for some people, me included.
I'm not an English major either.
Yeah. I mean, I can talk, but I don't like typing it.
Right.
Leveraging ChatGPT and things like that to help you craft better content is huge, to the point where like I've gotten to where, I don't know if you can do it, but you can just tell if it's AI content or not. Like
totally.
looking at something, I'm like, yeah, that guy didn't write that.
Yeah.
That's fake.
Right.
So you got to be careful in terms of like, a whole new paradigm with what we do of like,
Making it sound like a human.
making it sound like a human, but like it's also got to be in your own voice.
Mhm.
Like I'm the one writing the content. So if I'm just going to put something in ChatGPT and paste it over here, what's the point of me even being here?
Yeah.
Let's eliminate the middleman in this case. But like I looked at it as more of a enhancement to something I already had to do. This makes it quicker, more efficient, and a better product in the end, by leveraging that. Whereas before it was a lot of Google searching for pieces of content and, kind of coming up with ideas and writing it down to where what would take me a few days to write, now I can do an afternoon.
Riddled with punctuation mistakes.
Yeah.
Well, so we're touching on experimentation. Certainly a lot of that taking place in the ATC, our Advanced Technology Center. Part of that being that, the AI proving ground that we've been working with clients on. Chris, what are we seeing within the AI PG, the AI proving ground, that are good lessons learned that we can communicate out to the broader market?
Good lessons learned, I think the best one, we kind of talked about it earlier, is don't assume you know the answer to your problem. You might think you do, but it could be something different. So always keep an open mind when you're going into kind of that proof of concept experiment. It might not be what you came here for, but as long as you get the answer, right? That's the goal of any problem solving expert or endeavor, I should say, when you're going through it. There's many use cases and there's many different ways to solve that problem that you're going for. Keep an open mind was one of those things. Research, have a little, when we do proof of concepts, we always ask for like a test plan, a high level design.
Mhm.
So at least come into your problem solving with some knowledge, right? Sometimes we'll get folks from account teams that may not have the most information there, might have just an idea. So it's our job to kind of help them make what would look like a high level design acceptable, or even come up with a test plan. So if you come to us with a problem, you don't have to have all of the information right away.
Yeah.
That's okay. At least have an idea of how you want to get there and what you want to get there on, and it makes our job a little bit easier. And we can guide you through and walk you through creating a test plan, or even a high level design. You may not even know what you want to run this on. To your point earlier, I just got a GPU. How do I make this work for this problem? That's okay. We can help with some of that stuff. So lessons learned, though, going back to it, is kind of have a really good idea of what you're trying to solve, and have a little bit of knowledge about how you want to solve it. It may not be the right answer, but at least have an idea of what you're thinking.
Yeah. Let's pivot to the future here a little bit. Our GPU is going to continue to be the dominant force within AI and machine learning, or are we going to get into new architectures, TPUs, FPGAs, quantum computing? What's going to be the next iteration of GPUs?
I think we're not a ways off from it, right? I think GPUs are going to dominate for at least the foreseeable year or 2, 3, maybe even 3 years, right? But there's always something behind it with technology, right? There's always someone innovating on something else. DPU is a good example. Who would have thought offloading network functions from a CPU to a DPU to allow you to do real-time scanning was a thing, right? Cool. There's always someone pushing the bounds of that, right? I do think, like you said, GPUs are probably the foreseeable 3 years future-wise, but who knows how far quantum computing is behind that. I know HPE has been looking at it for a long time, among with others, right? Is the speed of light fast enough? in other regards, right? So I think everybody's always pushing the envelope, and I think that's a great thing about our human history. And for that realm, is we're always pushing.
Yeah.
Right. So is there something further down the path? Sure. Where we are today, GPUs is going to continue to dominate for at least a little while.
Yeah. Andy, what do you see coming down the line?
I mean, I agree with Chris. I think you're going to see just more iteration in the GPU space. You're going to probably have some different, niche cases come out of that too with, I need this type of accelerator for this particular use case.
Yeah.
But overall, on the whole, the GPUs are going to get faster. They're probably going to get smaller. They're probably going to use more power. Hopefully they use less power. I think you're just going to see, maybe a little bit like the CPU stuff between, that happened, it was like, you had one CPU, then you had four. Now all of a sudden you have cores. So I have this one CPU with 4 cores. That's the equivalent of 4 CPUs. So you see that kind of consolidation, if you will, of the technology's changed. So you can get things small, you get more in a smaller size or more in a smaller package, however you want to phrase it. I think you're going to start seeing stuff like that. What are the bottlenecks today between GPUs, CPUs, storage, all that stuff, and start, all of our partners are looking at those areas. If I have a bottleneck between, if I have a problem getting my data from this to this to this to the GPU, well, what are some things that are going to come up in between there that can, shorten that path, get things done faster? So you're just going to see further optimization of a lot of existing technologies, but also probably some big leaps and some new ones. Yeah, what those new ones are, I don't know, but like heavier GPUs are going to keep going. Yeah.
I'm going to backtrack a bit. I'll probably plug this in after the fact, but we know that GPUs are power hungry. So the power and cooling conversation is certainly a big one that's ongoing and has been ongoing for a while. When do those considerations need to take place? Is that before you plug in a GPU? Is it, like
before you buy it?
Yeah.
Like you really have to have a plan for, where are you going to put this, in terms of, what you're buying, the rack cooling, all of it. Do I have enough power in the road? And, it's like, we've hit the limits of it here in our facilities where we're building out a whole new section of it that's just focused on, latest technology with power, cooling, liquid cooling, all kinds of stuff.
It's emerging.
Yeah. Emerging stuff. I mean, yeah, when you're at the point of scoping out a project, if you're looking at buying this, you should have already had those thoughts and discussions with, your data center folks of, I want to buy this. Will it fit in my garage?
Yeah.
And will it work?
Yeah.
And can I do this?
And if you go too far without those considerations, you just have to rip it all down and start over. I'm thinking about putting together
a painful process.
Yeah. Right? Putting together like a kid's swing set. You got 3/4 of the way there. You realize you did something wrong, and then you have to undo it all.
Yeah. Maybe not undo it all, but you'll have to undo certain pieces of it, right? Power is a real problem in the AI space. Like Andy alluded to, we got some of this stuff in, and we were taken back by how much power it was actually drawing. And the new data center that we had was like, oh yeah, we're gonna not be able to power some stuff on, and we're gonna have to power some stuff down. So it should be your first thought with doing anything when you're getting GPUs or anything AI related, is how you compensate for that power and that cooling, because it could end up biting you in the end, and you may have to stop a deployment or stop something else in order to bring this one up online.
Yeah. Well, we're recognizing that things are only going to evolve and quickly, and that GPUs are going to get more powerful or more specialized, or they're going to change.
Mm-hmm.
Are the power requirements going to change? And so how can you keep up with that ever-evolving need?
I mean, we hope that the power numbers are going to go down as they get smaller, right? But so far, they've just gone up and up, right? And they're hungry for it, and they use it. It's tough to kind of predict that on where it's going to go, but I think every data center person that actually deals with power on a day-to-day basis they have to be figuring out how they're getting more feeds in. What does that look like for them? Some of these data centers at some point, are they going to have their own fusion reactor at some of these sites, right? Because how do you make it more sustainable?
Well, Chris, you mentioned the idea is that the power needs are going to go down. Would you say you're more on the hopeful side or confident side?
Hopeful side, right? I hope they, the engineers that are making these hardware components, I think they have an eye on that prize, right? I think right now they've got a great product and they've been asked to get it out the door as fast as possible. And I think a lot of that came, you didn't see that from like Intel's and the AMDs of the world either. When they started those battles for CPUs, it was like more cores, faster, more cores. And power was a second nature, right? And I think over time, some of the power requirements have gone down a little bit. I think the same thing will happen with GPUs. It's just a matter of time.
Yeah.
As they have more focus to do that, the engineers.
I would say, yeah, like once you've kind of maxed out your GPU, like just take the CPUs as like Chris was saying, and the general climate in the world has shifted to be more, climate conscious. So you have, all these things that use a lot of resources. The power plants burn coal, they burn oil, they're nuclear, whatever it may be, solar, and you've got these things consuming a massive amount of power. And you've kind of like the CPUs, you're pretty much at the top. I mean, you're going. And, what's another thing we can do? Oh, we now have a low power mode, or we have, we can start building these other features into our products that lower your costs for power, but at the same time also may require a new purchase. So it's kind of a self-fulfilling cycle there.
Yeah. Well, to the two of you, thanks so much. We're up on time. Thanks for dropping by and sharing your insight, your vision and wisdom. Certainly much appreciated. And, all the work that the two of you are doing and the ATC and the AI Proving Ground certainly helping, not only WWT establish a good sense about AI, but, setting a mark for the industry. So thanks for joining.
Thank you.
Thank you. You're welcome.
Well, thanks to Andy and Chris for the time today. Today's conversation leaves us with 3 critical lessons for any organization navigating AI and GPU adoption. First, don't buy into the hype without a plan. Many enterprises rush to secure GPUs without fully understanding how to use them. Now, they're realizing that optimization through fractionalization, workload alignment, and efficient scaling is just as important as the hardware itself. Second, AI success depends on skills, not just technology. IT teams must adapt and embrace new expertise to unlock the full value of their investments. Continuous learning and hands-on experimentation aren't just optional, they are essential. And finally, efficiency will define the future. As AI accelerates, power consumption and infrastructure demands will only grow. To succeed, you should be thinking ahead about sustainability, resource allocation, and how to maximize their investments in GPUs and beyond. If you like this episode of the AI Proving Ground podcast, please consider leaving a review or rating us. And sharing with friends and colleagues is always appreciated. This episode of the AI Proving Ground podcast was co-produced by Naz Baker, Stephanie Hammond, and Mallory Shaffrin. Our audio and video engineer is John Knobloch. My name is Brian Felt. We'll see you next time.